There is one other way that you can determine the delta H of a reaction, and that is using the enthalpies of formation of elements and compounds to determine the enthalpy for a reaction, or the delta H for a reaction. And this is actually one of the easiest ways to do it. So first of all, let's come up with a couple of definitions. The enthalpy for the reaction forming 1 mole of any particular substance from the pure elements in their standard state. So what you're looking for are elements that are in their elemental form at 25 degrees Celsius. So chlorine would be Cl2, but iron would be Fe. You're familiar with this. So standard state, the form most stable at the particular temperature of interest and at standard atmospheric pressure, usually 298, that's 25 Celsius, and 1 atmosphere of pressure. By definition, the standard enthalpy formation of the most stable form of any element is 0. So Cl2 is 0, F2, 0. All the diatomic elements have an enthalpy of formation equal to 0. Okay? Iron, sodium, potassium, cobalt, all of those are elements that want to be monoatomic. Their enthalpy of formation is 0. Okay? For compounds, it's the enthalpy of formation reaction forming 1 mole of a substance. And you have to actually look those values up in a table. Now, you're fortunate in that I'll give you the table. The way you determine the delta H for the reaction, where's my pen? The delta H for the reaction, and notice this little tiny 0 up here. That little 0 means standard conditions. Standard conditions. And who determines what the standard conditions are? We do. We state what the standard conditions are. What are they? 1 atmosphere of pressure, 298 Kelvin. Those are standard conditions, and that's what that little 0 right there happens to mean. The way we calculate the delta H for a reaction using enthalpies of formation is really simple. We simply add up the enthalpies of formation of the products, and we subtract the sum of the enthalpies of formation of the reactants. So we add up the sum of all the enthalpy of formation for the products, and then subtract all the sum or all of the enthalpies of formation of the reactants. Now, what's this N here? That refers to the number of moles of product. And what's this M here? That refers to the number of moles of our reactants. So delta H of the reaction under standard conditions is just the enthalpy change for the reaction. This little sigma here is sum. N and M stand for moles. And delta H of formation is the enthalpy of formation of 1 mole of a substance under standard conditions. All right, so let's get to the actual problem. What I'm going to do is I'm going to switch to a Word copy of this problem. Let me get my pen. There we go. Boom. Yep, everything's good. And so I'm going to reiterate. Here is my reaction. Okay? I don't know the delta H for this reaction. I'm given a table of enthalpies of formation for 1 mole of each of these substances. So there's the delta H of formation for each of these substances. So here's how I'm going to set it up. The delta H for this reaction under what conditions? Standard conditions. How do I know it's standard conditions? Because I got that little 0 sitting up there. Is equal to, and I'm going to go ahead and make a set of brackets. Now, what I need are the products first. Let's go with carbon dioxide. Now what you need to remember is that the coefficient of carbon dioxide is 3. If I look down here at carbon dioxide, this is the delta H of formation for 1 mole of carbon dioxide, so I need to multiply it times 3. And I include the sign and everything. So this is 3 times a minus 393.5 kilojoules per mole. And I'm going to add the 4 moles of liquid water. So that's plus 4 moles of water, and the water is minus 285.8 minus 285.8. All right, let's make a better 8. Those are my products. I'm going to subtract from that the enthalpy of formation of all of my reactants. Let's start out with propane, C3H8. I have a coefficient of 1, and there's the delta H of formation. So that's just going to be minus 103.85. 103.85 kilojoules, plus 5 times the enthalpy of formation of oxygen. Oh, wait a minute. Oxygen is an element in its standard state, and the enthalpy of a formation of an element in its standard state is 0. These are my reactants. So it's always products minus reactants. And when I add that up, I wind up with minus 2200, actually minus 2220 kilojoules. So that is my delta H for this reaction under standard conditions, minus 2220. That's pretty sloppy. Let's take a look at it a little bit better. Minus 2220 kilojoules. My delta H of reaction under standard conditions. That is all there is to calculating the delta H of a reaction using enthalpies of formation. What you have to remember is products minus reactants. Make sure that you multiply by the coefficients from the balanced chemical reaction for each enthalpy of formation. My recommendation would be to use brackets to enclose your products and your reactants to keep from making sign errors, because you know that this minus times a minus is actually a plus. So I would recommend using parentheses or brackets, particularly once you put this in your calculator. And that, ladies and gentlemen, is the end of Chapter 5.